All right, class, in our continuing study of transformations, we want to now look at reflections. And when we think of a reflection, I want you to think of a mirror. Just picture yourself looking in a mirror, and you know what a reflection looks like. And that is essentially what we're doing. We are going to be mirroring pre-images to create a new image. But we also have to have what we call a line of reflection. And if you think about it, if you stood 2 feet from your mirror, your reflection is going to appear to be about 2 feet into the mirror. If you take one big giant step backwards, you're going to do the same thing in your mirror. You're going to get a little bit smaller. It's going to look like you're now a larger step or a larger distance away from the reflection. If you moved closer, you will see your image, your reflection getting closer to yourself. And so that's essentially what we're doing with reflection. So we need to think of a mirror and to think of a line of reflection. And so let's look at a couple of quick examples here. You can see that I'm starting with my pre-image, triangle ABC, and I am reflecting it across the x-axis. Now I'm reflecting it across the x-axis. Now that's important because one simple way to do this is to see, well, how far is it from A to the x-axis, which is my line of reflection? It's 2 units. Oh, well, that means I have to go across the x-axis 2 more units. B is 2 units from the line of reflection. Then I have to go another 2 units. C, look at that. What is that? 1, 2, 3, 4, 5 units? Well, I've got to go 5 units to C across the x-axis. And that's it. Yes, they do get a little more difficult than that, but that's a line. That is a reflection. That is a transformation that is known as a reflection. In this case, we are reflecting across the x-axis. All right, let's look at this next example. Here we have our pre-image ABC, and we're going to be reflecting it across the y-axis, which is also our line of reflection. So in this case, it's the same process. I'm going to look at the distance from A to my line of reflection. That's 2 units. I'll go 2 units there. And you can see that all of these, they form a symmetrical image, if you will, a scenario where everything is symmetrical. The pre-image, ABC, across the y-axis to the image, A prime, B prime, C prime, and I'm just going to be going each point the same distance from the line of reflection. And what does it produce? It produces my image that's across the y-axis. Notice, I think this might be helpful. A is here. It's closer to the line of reflection than B. That means A prime is going to be closer to the line of reflection than B prime. Okay? And so you got to think it like it's flipping. If this were a translation, now I hope this doesn't mess anyone up. If this were a translation, C1 or C prime would be the same. But this would be A prime and that would be B prime with a translation. Because with a translation, I'm not reflecting anything. I'm simply sliding it. You see the last video, or at least the video on translations to help you with that. But that's a big difference between a reflection and a translation. So why don't we try a practice problem or two? I've given you 3 practice problems. And let's stop it right there. And so give these a good go here. I've given you the instructions below. Reflect across the y-axis, x-axis, and across x equals -1. So that's going to look a little different. Pause the video and come back and I'll work them. All right, now that you have done that, we are going to reflect across the y-axis. So that means my line of reflection is here, the y-axis. B is 1 unit from the y-axis, so B prime would be 1 unit. A is 1, 2, 3, 4, 5, and so it's going to be 5 units from the y-axis, so 1, 2, 3, 4, 5. That's A prime. C is 3, so C prime would be there. And that is, again, the simplest way probably to see a reflection, and that is a reflection across the y-axis. Number 2 is going to be reflected across the x-axis, so my line of reflection is there. F prime is going to be 1 unit above. Now notice that the x-axis, if I'm going across the x-axis, the x coordinate stays the same. And all I'm really doing is changing the sign of the y component. And so if E is at 1, 2, 3, 4, 4 in the x, and 1, 2, 3, 4 in the y, so that's negative 4, E prime is going to be 4 in the x, but positive 4, 1, 2, 3, 4. E prime would be here. And all I've done there is, go ahead and you can start seeing the shape come together. All I did was change the sign of the y component. Now that's going to help us with some coordinate notation that we'll look at the bottom. D prime is 1, 2, 3, 4 units, so it's going to be 4 units up. And there's D prime. And again, you can look at that from a coordinate notation standpoint as well. But that's the reflection across the x-axis. Well, now what about if we want to reflect it across y equals negative 1? Now this goes back to our graphing, y equals mx plus b. There is a zero slope. That means it's flat. So there is no x coordinate. All right, it's actually going to be a horizontal line through y equals negative 1, and that becomes your line of reflection. So now for b, rather than measure the distance between b and the x-axis, I have to measure it between b and the line of reflection, which is 2. So I'll go up 2 units, and there is b prime. A prime is 2 units, so I'm going to go up to, A prime is going to be 2 units. And so C, that's going to be 1, 2, 3, 4 units from the line of reflection. So I'm going to go 1, 2, 3, 4. And that would be C prime. And D prime, let's see here, is going to be right there, using the same process. So that is a line of, a reflection across y equals negative 1. So you have to be very careful to think about where that line of reflection is. Now you'll notice that the coordinate notation is not going to work here. Like, in other words, these that we'll review in just a second that I just explained for problem 2 will not work if the line of reflection is not across the x or the y axis. So I can't just come over here to say B and start changing the y component. That doesn't work. Let me illustrate that really quick. B is, let's see, that's 1, 2, 3 in the x, and looks like negative 3 in the y. But I can't just change it because b prime is going to be 3 in the x, but it's 1. It's 1 in the y-axis. So you'll notice that I can't just change it. And so when you think about the line of reflection across the x-axis, I'm going to take a point on the polygon, upon the shape, like we'll take D here, for example. And notice that x stays the same. X stays the same, but look at y. All I did was change the y value because I'm reflecting across the x-axis. Now you've got to try to visualize that, how going across the x's are going to stay the same. And you can see it right there across the x-axis. D and D prime have the same x coordinate. F and F prime have the same x coordinate. E and E prime, look at that. They're on a line. They have the same x value. Notice over here with number 1, C. Look at this. Their y value doesn't change. They go across the y-axis. And the same thing for AB and A prime and B prime. The y value does not change. So for a line of reflection across the y-axis, and I start with a point, notice it's the x. I change the sign of the x, and the y stays the same. All right, guys, I hope that helps with reflections, and make sure you send me any questions.